Hi everyone, today I tried to model the growth of slime using Excel and I'm going to talk a little bit about how I did that. My child and I watched the Nova episode Secret Mind of Slime last night and it got me thinking about how complex behaviors can emerge from relatively simple rules. Essentially, slime is a single-celled organism that behaves in some surprisingly sophisticated ways. Here's a screenshot showing slime growing. There's a big blob of it in the lower left-hand corner and it's growing out in multiple branches or tendrils. Now, it's beyond my current math skills and especially my current technological skills to model slime in all its complexity. However, I thought I could model a simplified version of it. So my slime only grows in one direction at a time. In other words, it won't have multiple branches or tendrils. Now, it may turn and loop around, but it will only grow as one single strand or tendril. And to start, my slime will grow completely randomly. To do this, I started my slime at the origin in the coordinate plane. So this dot is the start of my slime. To model its growth, I added a random amount to the x and y coordinates. But I didn't want it to grow too much or too little each time, so this ring shows all the places my slime could grow to in one step, in one time interval. Essentially, I had Excel choose a random spot within that ring. For example, maybe my slime grew out to here. I had Excel record the new coordinates, and then I would repeat the process. For the next step, I would be starting with the second dot, and I can grow to anywhere within this new ring, so my slime might grow out to here, for example. This would show the first two steps of the growth of my slime. Each new step in the growth process is represented by a new row in Excel, so my spreadsheet has about 1,000 rows to show 1,000 steps of growth. Let's look at an example. I have some slime starting at the black dot, and it's going to grow randomly. We'll see whether it finds its way to the food source, shown by the gray dot. Here it is after 10 steps and 20 steps, and now 50 steps and 100 steps, and you can see it's not heading towards the food at all, it's just following random changes. Here's 200, 300, 400, and 500 steps. You may notice it's looping back over itself a lot. This is something real slime does not do, but my simplified slime does. Here's 600, 700, 800, and 900 steps, and it's headed off in a new direction. And my simulation ends at 1,000 steps. This is just one example of what could happen. If I have Excel recalculate the random values in my spreadsheet, I'll get a completely different path. This slime is pretty boring because it's completely random, so I wanted to add some behavior to my slime. I decided it should be able to smell a nearby food source. If you recall, my general method so far was to have the slime grow by adding a random amount of change to its coordinates somewhere within this ring. Because it can now smell the food, I'm going to make that less random. To do that, I add a specific deterministic change pointing the slime towards the food. Then, to balance out the randomness of life with the exact formula, I average the two changes. So there's some random component and some deterministic component. This means that the slime will not always go straight for the food. Sometimes a random component will be larger and more powerful and will actually pull the slime away from the food. Let's look at an example. Again, I have my slime starting in the middle where the black dot is. Let's see how it grows. Here it is after 5 steps, 10, 20, 30, and 40. We're clearly headed in the right direction. Here's 50. At 60, we're almost there, and you may notice it was a pretty significant jump forward. And in 5 more steps, we're at the food. In the simulation, as the line got closer, it moved more rapidly towards the food. That's because I wanted the intensity of the smell to increase as you got closer. To do that, I used the logistic function, which looks like this. Technically, it may have made more sense to use something like 1 over x squared if we imagine the particles from the food spreading out in a circle. However, the logistic function had some nice features that made it easy for me to adjust to try out different scenarios. Finally, I wanted to see what would happen if I changed how strongly the food affected the slime. We can think of this as the food being more or less smelly, or we can think of it as the slime having a better or worse sense of smell. So I ran multiple simulations, sometimes with the max strength at 1, but other times I squished this function down so it peaked at a half, a quarter, or a tenth. Then I made a graph showing all these different scenarios at once, and I ran the simulation 10 times. In this simulation, the red slime can't detect the food at all and grows randomly. That's like the very first slime we saw. The orange slime is slightly affected by the food, but due to the random part of its growth, it heads towards the bottom. The green, blue, and purple slimes, which are more sensitive to smell, all reach the food. Here are a few more simulations. On this one, the red slime actually reached the food by random chance, and it did it slightly faster than the yellow slime. When we look at all 10 simulations together, we can see a pattern. The blue and purple slimes are much more consistent and faster at getting to the food than the others. So what? What's the point of an activity like this? First, it demonstrates how simple rules can result in more complex behavior. With some additional rules, like not returning to where it has been, slime can behave in some surprising ways. Second, it shows how we can use spreadsheets to run mathematical models that include some randomness. These are called stochastic models, and they're valuable in a wide range of fields, including modeling biological processes. Third, it was fun. I enjoy trying out new things, and it helps stretch my thinking. In the description of this video, I've put a few links to some resources I drew on in developing these ideas. Thanks for listening. Please send me your math questions about this video or anything else at mathymatfk@gmail.com or leave a comment on this video. And don't forget to like and subscribe.
Math's not a problem with mathematics.